Actually, you know what? You know what? I'm calling this a game engine. Okay, fine. We can give in and call it a game engine. OpenGL game engine C project. No, OpenGL. Uh, OpenGL and C. Game engine dev. There we go. I think that's fine. Okay, I'm admitting it to myself. This is a game engine. It has a physics system, it has components, it has a fucking light mapper. It's a game engine. It's fine. All right, buckle in. All right, so where I left last night, I realized that the probes needed to be a 3D texture. I guess I was just fucking stupid that I didn't think about that. But yeah, once I started pushing the ball around, I like realized, oh, it's not gonna interpolate. Duh. So, hey, what's up, cheese? Yeah, so I needed to be a 3D texture, and so that's what we're gonna do. It is pretty cool to just push the ball around and see it, change color or whatever. The top of it stays black because there's no probes above it, of course. How am I doing? I'm doing all right. I'm fine. Very cool to push the thing around. We do have to do some impulse solves, I think, against it. But I've taken some notes. I've taken a few notes on it. What is that over there? Why is there? Oh, right, because underneath it is bright, because that's where the light is. Explain what I'm seeing. So basically, we have probes. So each one of these squares is a different lighting probe. And so we have to put them in a 3D texture so that they can be interpolated between one another. Because right now it's just hard. These triangles are getting this lighting probe. These triangles are getting this other. We have light here. We have different colors of lights. So that's why it looks like this. And we have a light coming in from that direction. In fact, if you want to just see what the scene looks like in general, we can just do T times light. And then you can see what that looks like. Just to understand what's going on. So we have these lights up here, and then underneath we have this light, right? And so what's happening in the other view is we are seeing what the lighting probes is like. The point is I want to get real-time lighting for this, or not real time, but dynamic lighting for the dynamic objects, so that when they move through different things. You know what I mean? Did I start a new project? Yeah, I guess. This isn't the space project now. Alright. So, I wrote a bunch of notes down. These are the notes. Okay. These are the notes for the physics stuff today. So first of all, we need to pre-compute per mesh inverse inertia, which is this formula, and then I think we have to put it over 1. I'm not sure, but I think that's basically what we have to do. We can put it in a vec3 for now. It's usually in a 3x3 matrix, but I think we can just put it in a vector. Okay, then this is the rest of this stuff is on collision, right? So on collision, we get the current velocity of A, and then the current velocity of B, which technically I think doesn't require any of this stuff because we're just getting the current velocity, right? We need the current velocity because we need to find the relative velocity of B to A. We're solving for both, right? So basically you have two objects that touch and you want to solve for them separately. So we have the velocity of B minus the velocity of A. This R is what we use for the torque. This is the contact point minus the center of mass for the object. And so this happens for each object, I believe. And then this J is basically the force component. What I don't understand is this. This I don't understand. This I did not understand. But this is how we get the rotation to be a part of it. We get the Vn, which is the dot between the relative, this velocity, and the normal. The question is what normal? See, that's the part that I didn't get, is which normals is where. That part is confusing to me. So we're probably not going to implement this specifically because this is confusing to me because NA and B doesn't really make sense to me. Anyway, I might have to look it up. So then it's just force times inverse mass times dt, which I believe force I think it's J. God, yeah, they should never make me take notes, huh? Let me just look at what I had earlier. It might actually be the impulse. It might actually be the impulse. And then we cross this R with the impulse to get what we use for the torque. So yeah. Pretty fucking complicated, right? Pretty fucking complicated. But if we're thinking about just solving for a static plane like we have, like a box on top of a static plane, we can probably think about this a lot simpler than the way we have it right now. It probably doesn't have to be that crazy. Yeah, let's put it back onto the normals view. Just for simplicity's sake. We have two things we could do. We could do the lighting probes, or we could do the physics stuff first. I think I'm going to do the physics stuff, or just to try it, because I think it's fun. Because I think it's fun. That's all. Okay. So we're going to need to make some room. We are going to need to make some room. So apparently, if you're doing a physics solver like we're doing for rigid bodies, we aren't supposed to be changing the proposed position. We're supposed to be changing the velocity, which I already do here, to be fair. You're supposed to change the proposed position by a little bit, but not by a lot. It's supposed to be mainly the velocity. Okay. So inside of collision points, this is the struct that we pass through, and we get A, B, normal, D in collision. What we want to kind of get, well, we'll just do 1 point this time, but what we want to also get is the physics component that we hit. If we hit one and we push it, the thing is we want that physics component that we hit, but we don't know what it belongs to. We only know the node. Yeah, how do we get from mesh node to physics component without just looping through all the physics components? We could have mesh nodes also have a pointer to a physics component as well. That may be getting like a little bit hefty, but I think that that's actually the simplest thing, is that a physics component also can be referred to on a mesh node. That makes sense to me. I need to forward declare this. We're just going to move this up because I'm lazy. And now when we assign a new entity's physics component and mesh node, we will put on that mesh node the physics component. We do have to, when we initialize a new mesh node, though, we do have to set it to a new mesh node. We do have to set mnpc equals null. Okay. So now that we have that set up, we don't actually have to do any search at all, because every mesh node has a collision component. So if GJK, then P, we want to put onto P collision points. We want to put onto P a pointer to a physics component. God fucking damn it. Okay, we have to forward declare it. I was trying to not forward declare it because I hate doing that shit, but Alright, where are you, you bastard? Wait, why is it not mad at me? Don't you have to remove the... Did I name it the wrong thing? Oh, no, you have to just get this. Okay. Okay. So PC equals the MN... Yeah, MN PC. For now, we only have one contact point that we're generating per frame. So for now, it's just that. So now we have a physics component of the object that we're going against, if it exists. So what we need to do is, if we find, right, so let's just make it very simple. So VA will be the current PC val. Let's do that. And then VB I don't know which one's supposed to be A and which one's supposed to be B. I'm going to assume that we're A. And then VB will be the P dot... Well, first of all... equals 0, 0, 0. And then if P dot PC... then we can go VB equals P.PC val. That's simple. Okay, so I'm going to assume that each physics component needs a center of mass. For now, that center of mass can just be the mesh's centroid. Yeah. What, in your opinion, is the most useful programming language to learn? That's hard. I mean, it depends on what you want to do. You know? Definitely depends on what you want to do. It also depends what type of person you are. Like, if you're someone who likes to, like, use other libraries and stuff, then you can learn, like, Python and get, like, a lot of mileage out of it. If you want to build your own stuff, then you should learn, like, C, you know? It depends. I'd say that, I mean, I'm kind of, like, really biased here, but I'd say that C is probably the most universal language you can learn, right? Like, there's not, like, anything that, you know, C can't do, you know? It is the fastest language. It is literally the fastest language and will always be the fastest language because it's the closest to assembly. You can't really get closer than it. And so other languages can try to be as fast as C, but, you know, I think that at the same time, it's also a very simple language. You would think with something that's so low level, it would be very complicated, right? It would be hard to understand, like assembly or whatever. But it's not. It's very, very simple. And so I think C is kind of perfect in that way. Okay. Yeah, I think we'll just use the... I'm just thinking, do I want to cache that on the PC or on the mesh node? I think I want to cache that on the PC. So on our physics component, we'll put in here a center of mass. That makes a lot of sense for it to be on there. And then we want to have also a inverse inertia. I don't wanna talk about it. Okay, so when we initialize a entity, we want to probably have a function that initializes the PC. And it will take in a mesh node because we need to use the mesh node to get the center of mass, which is just, we're just going to do the centroid for now. I don't wanna talk about it. And we will take in a physics more important PC. Okay. So first of all, we have to get the mesh node. Okay, so PC center of mass equals mn. We don't have an AABB actually here. We have to get the mesh from it. This is the GitHub dark theme. I kind of fuck with this. I'm not gonna lie. I know it's kind of basic or whatever, but it's kind of cool. It's pretty readable to me. I don't usually like a lot of syntax highlighting, but I think it's good. Okay, so the center mass will equal the MAABB.center. Mass will equal 1 for now. You're eventually going to obviously want to... We could probably scale the mass with how much, how much space it takes up, but I've used Moonfly. It's Moonfly. It's not on here. I'm sure it's good. Okay, so inverse inertia. This is the fucking complicated one. This is the fucking complicated one that I was talking about earlier. So I don't know if this is inverse inertia or if this is regular inertia. I have to look it up, actually. So, calculating inertia for a cube. Let me see. Calculating inertia for a cube. This isn't giving me the right thing. Calculating inverse inertia for a cube. Yes. Calculating the inverse matrix, because this is calculating the involves just finding the reciprocal of each diagonal element. So it's 6 over ml squared. And what I have is... Why is it 1 over 12? Huh. Well, at least what this is saying is that it's 6 over ml squared. What is L? Side length L. Oh, so that's probably what this is. Height plus depth squared. Huh. Yeah, I don't really know how the math works out, but I'm going to assume that that's correct. either way, even if this is 1/6, then you want to get the reverse of this for inverse inertia, so 6 goes on top. So this would be 12 over ml squared. Yeah. Okay, so for inverse, I'm just going to write that this is 12 over this. Apparently, according to fucking Jarvis AI overview, because I tried to read some other sources on this, and immediately I was like, okay, fuck you. I don't know. It was like really, really confusing. It's like so fucking confusing. Okay, so we're gonna use the extents to calculate this. So obviously, I think height is gonna be z, depth will be y, and then x will be width. So just to be very clear here, the width is going to be mabb dot extents dot x times 2. And then you're just going to do the, because this is a side length, right? Depth, height. Okay, there we go. Because we're z up supremacy. Who's with me? Legit, I could not imagine doing anything not z up. Like, seriously. Especially game engine wise. It just is locked in my brain, z up. Okay. Inverse inertia equals 12 over the mass. Let's just make it its own thing for a sec. Just so that we're clear here. And then it's height squared times depth squared. So let's just write this. I'm sorry that I'm being so, clear with this, but this is confusing. So H2 plus D2. And this will be X. And now this is usually in a matrix, and in a matrix going sideways, but the way we're going to be using it is not just as a vector anyway, so it's like whatever. And then this is width times depth, and then this is width height. Okay. Let's hope that I have any clue what I'm doing. If it's not this, then it's 6. Try 6 after, because I'm not sure. Because I looked it up. What I looked up was a cube. This is supposed to be possible for a rectangle. That's why we have height and depth, right? It's just a bounding box, right? So I'm hoping that this is fine. Now here's the tricky part, is that even though we've set this up and with the center of mass, we now have to transform that center of mass by the model matrix, right? So let's go vec3 current COM equals PC center of mass, and then we want to mat for mole point with motherfucker. We do need to get the mesh node because we need the the matrix, yeah, to transform this point. Yeah. We do need it. Yeah. Okay, let's figure out how to get it. Let's just go mesh node pointer mns. We're gonna cast vec globals dot mesh nodes. Yo, what's up, Mude? What's up, Kat? It's going well. It's going well. I'm doing some physics math right now, which is pretty scary. I already have MNs actually, so I just need to get it here. I'm just gonna get mesh node pointer MN, or do I even have that? Do I already have that? I do have MN. I get it at the top, so this is perfect then. So MN local matrix is gonna transform our current center of mass. Okay, so now that we've transformed it by the matrix, now if we're going back to the formula here, our R is our contact point, which is P dot A by the current COM. Looks scary to of 4 hack the box lab. Sucks, but I'm learning something and it feels good. Interesting. Is that like a one of these like coding challenges sort of things? That's interesting. Yeah, I try to do some of those exercises. They're pretty fun, to be honest. At least the ones that I tried online to learn like modern C++. Okay. Yeah, okay. So to get the relative velocity, we're just going to do VB VA to get the relative velocity. Hopefully that's in the right direction. I have no clue. Wait, actually we have this here. To get VN, we did wish against the normal. Huh. I have a feeling that this is backwards, because this is just going to give us a negative velocity when our wish is always supposed to be a positive velocity. So I'm going to guess that this is the other way around. If we are VA and we're solving for VB, makes sense for it to be the other way around. It's like old Java with pimp. I can't even look syntax of it. I agree. It's, I don't know. It's a bit silly. I also don't understand like the very complex stuff, like virtual stuff. I think I understand some of the virtual stuff, but like some of the more complex examples, I just literally couldn't get through the examples. It was just so fucking confusing. Actually, it's really simple Linux simulant. You just need to answer really easy command. Copy, paste the thing in text file, but this is for beginners. I see. That does sound fun. As long as you're learning stuff. Yeah, modern C++ is crazy. It is crazy. It's kind of, I think the modern C++ thing is kind of like, it's got like the same vibe as like an MMO that's like now 20 years old, and it's got like 20 different expansion packs, and now there's just like, it's just so bloated that there's just so much fucking shit in it that like nobody wants to have. That's, it's like WoW. At Rockstar Games they use C++, but they just use plain C. Yeah, I think that's the way you have to use C++. You compile it as C++, but you write C. Yeah, Rockstar Games. I wish that they would have hired me. That would have been really cool of them. but we're not living in that timeline. So yeah, it has to be VA minus VB, because if you don't do it the other way, if you do it this way around with VB minus VA, then if the other object has 0 velocity, then now we have negative velocity. So that can't be right. So now the new Vn that we're getting for this example is going to be the relative vel and the in the contact normal. And now only if Vn is less than 0 is where we continue processing the impulse. Okay. So this J is the big one. We actually computed this a little bit down here with this restitution. This is basically what it is. But yeah, I think it's different. Yeah, it's different, right? So for now, we'll have let's just have, oh, actually that needs to go onto the physics component system. This needs to have a float restitution, which is just how bouncy it is, right? And when we init it, we'll set it to, for now, we'll set it to 0.5. It's just a little bit of bounce, just to see how it works. This was what we were testing with earlier. It starts at 1 and then you go 0.5 on top. So this is negative 1 plus PC restitution times the Vn, and then we put it over 1 over it's just the inverse mass of PC mass, and then so you don't want to divide by 0, so let's get it up here. Yeah, let's just do this the same way, because you want this to be 0. Oh my gosh. Okay, so now both of our objects have inverse mass, which is what we want. Well, you can also pre-compute that, right? But we're just gonna do it this way for simplicity's sake now. So inverse mass B. Okay. Now this is the formula without rotation in it yet. We can have angular velocity be computed. This formula, the rest of this, I don't really understand. It's not that I don't understand what I need to multiply here. It's this specifically. What is, I get the RA, right? We already have the R. What is this normal? See, this is the part of the formula I don't understand, because I copied this down, but how do I have two different normals? I have the obviously the contact normal, but why did, when I looked up the formula, it gave me these two. Is this just as game engine or a full graphics engine? This is my personal, this is the second game engine that I've made. And it is with OpenGL as a rendering backend, yeah. But it has, so far, it has a UV light mapper. It has the beginning of lighting probes. It has this physics system, collision system, and obviously, like, you know, you can load in meshes, right? And makes holes that are convex, and it also makes acceleration structures over scenes and with the individual triangles themselves. That's everything that I have implemented so far in this thing. So I don't have a UI system yet. I don't have a UI system yet. I don't have like fancy dynamic lighting yet. I don't have like entity behavior or anything like that implemented yet. Things like that I still have to work on, yeah. But we're getting along. Right now my job is to create it. So right now I have it so that we can, let me see if I can show off. I don't think that I have any lighting turned on. Yeah, it's just the normals. But I just want to make it so that when I push around this mesh along this other mesh, I just want to see it rotate and bounce around. So that's the physics stuff that I'm trying to do right now. If you want to see what the lighting looks like, because I had the lighting off, then you can see what it looks like here. It's very simple. It's not anything complicated, right? This is just a light is coming from this way, and then we just have point lights on this side. So it's nothing crazy yet. It's nothing crazy. Anyway. Okay. So for now, this is just going to be the function. Okay. So static objects obviously get 0 inverse mass and 0 inertia. 0 inverse inertia, which I already, impressive. I'm not an expert, but I'm guessing for lighting, hardest part is having gravity physics around it. Yeah. So that's so as you could see, that mesh was black with the lighting. What I'm gonna be working on today is getting the lighting probes. Lighting probes are basically just points in space, right, where you bake lighting so that later you can sample it as a texture. So as I push around the mesh later, what I'm going to be implementing is basically it's going to sample the lighting as it moves around, which I think is going to be pretty fun. It's actually not that complicated to do. I think the hardest part is actually, at least with the light map stuff, is really unwrapping the UVs is pretty brutal. But I'm glad that part is behind us. That part is like the hardest part, at least for me. Historically. This time it wasn't that bad. Alright. But I appreciate you calling it impressive. I do appreciate that. So inverse inertia, and for here, once again, we're going to start it at 0, 0, 0. And then we'll do the same thing here, where if there is a physics component that we find for the second object, then we'll set it to inverse inertia. Okay, so moving on here, our impulse equals J times the normal. Which I'm not entirely sure about. Right, this is... We're going to scale it by J. I'm not sure about this. Maybe this is basically what's happening here, actually. But yeah. Now our velocity is plus equals the impulse times the inverse mass times dt. So let's just add it into the regular velocity here. Just the internal yeah, let's just do it this way. basically the idea is that you would solve for both objects at once. If an object collides into another object that's also moving, then you want to solve for them both at once. So that's why you have this different thing here. I'm kind of like worried about that, because then how do I make sure that when we're updating all the physics components, then we don't solve for the same thing twice? I don't really know what the solution is there. Anyway, so that's the velocity taken care of. We need to also have on here angular velocity. When we init a physics component, we also need to set PC vel to 0, 0, 0, and we want to set the angular velocity to 0, 0, 0. The way that I had this described to me earlier is that if you have a 5 here, then it's rotating around the y-axis 5 RPM. So that's what it is. Okay. So now this value torque is the R with the impulse. And then let's just have another thing here. We don't want to add directly into the velocity, I think, because then you probably end up having like additive stuff going on during your solving. Hey, what's up, VFeek? Okay, angular velocity dot x plus equals the, okay, so this is the part that we have to pay attention to. So inverse inertia a dot x times the torque dot a dot x times dt. That should be correct, because the way the multiplication, the matrix multiplication would be x times x. So I think that that's exactly correct. Thinking of starting to learn how to code. Like, I've always had a billion ideas of games that I want to make. Should I just start with Python? It depends on what you want to do. Like, if you want to make something from scratch, then definitely don't use Python. You can use Python if you want to like make something with Pygame, but I think that that's mainly a 2D thing. If you want to get into 3D programming, then I think the only real like sane option is a, you know, a low level language like C or Rust or whatever, you know, or C++ or whatever. I think that those are really the places you should start, personally. Okay. Now we do want to push out from the surface just a little bit, but that's not the main thing here. So I'm just going to do just a little bit. We're just going to push out by a little bit. And then at the end, we will validate the velocity, right? So PC vel equals vel, PC angular velocity equals angular vel. And then I copy down this orientation function earlier, which was admittedly, you know, very confusing to me. The orientation is our rotation vec4 that's inside of the mesh node. So in this case, it would be mn rotation. First of all, let's just do this separately. How did I start? I started with C. At least the first game engine I made was C. in terms of 3D programming. I haven't actually done like 3D programming not in C. But I'm making a game engine right now. It's very simple right now. It's I can just show you what it looks like. There is lighting and stuff. I'll actually turn that on for you right now, just so that you can see what it's supposed to look like. But right now I'm working on the physics logic. But yeah, this is just what it looks like. This isn't light mapped, it's probe lighting, but I don't have it on right now. But yeah, that's just what it looks like. Thanks, no problem. No problem. Okay. Okay. Zero 0.5 times the vec4 of angular velocity in 0. And then we scale it by... We scale rot by 0.5. Then we multiply it times the orientation. Mn rotation times rot. Let's just write it the other way so that it makes more sense. And then scale it by dt. And then we go mn, and then we normalize it. I don't have a vec4 normalize. Okay, well, I have to write that real quick. Where do I have this? In mathf? Okay. Is this C? It is. It is. Thinking of making like something low poly stalker. That's awesome, yeah. I love stalker. So if I want to make a game, I have to make the engine first, and then I can like build the game. Or do you make engines like in layers? I think that in terms of making like a game engine from scratch, it just has parts of it, right? So you have like sound, you have the physics, you have the animations, you have the lighting, you know, so it's all different parts, right, that you can work on at separate points. So yeah, it's not that complicated. It just takes a long time. It just takes a long time. Like, you know, the first engine I made, I didn't really finish it, and it took me, you know, like close to a year probably. But at the end of it, I had a full thing going on, yeah. Okay, so mn rotation equals vec4 add mn rotation. Wait, is it? No, yeah. You just set it to rot. Just set it to rot. And then we compose a new thing. Okay. Well, let's give it a shot. I don't really know what the fuck the code does because it's just It's just math, but we're gonna give it a shot. Hey, what's up, three-leg chair? You have to go to sleep soon? That's completely fine with me. I was in the middle of writing a line last night, and then, you know, that's why it's not. So now I can use Unreal Engine, Godot, and Unity, but I hate having to learn engines. It's boring and shit. Yeah. That's why I made my own engine, because I didn't like using other engines. I just didn't like how they felt. Okay. Let's see that again. Okay, it just fucking gets it gets fucking obliterated. Okay. It gets obliterated. Let's try none of this angular velocity shit. Huh. Okay. So I'm guessing it has to do with that. Yeah. What's the code editor or Telix? Are we still on the lighting part? No. No, I'm working on the physics right now. Did I add collision to the floor? Yeah. Yeah. How other engine felt? In what sense? Well, I was like 15, 16, and I like really wanted to make a video game, you know? When I was younger, I would have like notebooks filled with like drawings of like, you know, my video game that I wanted to make. Like I would obsess over it in class and stuff. And then I stepped 1 foot in Unity when I was 15, 16 years old, and I was like, wow, this is fucking awful. I don't know. It's just something about it. It's just so general, and it doesn't have any character, and that's kind of why all of Unity games like kind of feel the same, you know? Like the games that I grew up playing, like Quake and Unreal and stuff, they had their own unique, you know, physics, collision, like movement code, you know what I mean? That was completely, you know, it was the identity of the engine itself, you know? And so you can make like a general engine like Unity or Unreal, or Unreal Engine, but it's never going to feel like that, you know what I mean? It's never going to feel like that. I don't know what the mass is supposed to be, but let's just see what J is. J is 0. How is J 0? Maybe VN is 0. Why would J be 0? Alright, peace out, three-leg chair. Do I work with Unreal much? No. No. Hey, what's up, Lexi? Because the UI is confusing? Yeah, the UI is pretty confusing. How is J 0? I mean, Vn is pretty small, but it should be over 1. Our mass is 1. Unless I fucked that up somehow. Let's just see all of the values printed out. In PC restitution, inverse mass A is inf. Did I not set it? I did. I tried all the guys, it was just boring. Should I use this site to learn your first programming language? I feel like learning the language isn't hard. It's writing the code that's hard. Inf. Do I touch it anywhere else? Let's see if I just hard code it to 1. This makes no sense. It's just supposed to be 1 over 1. Why is it inf? Like, that's what it's supposed to do. So the math isn't wrong. What is PC mass? Should just be 1 over 1. What the fuck? It's 0. Oh my gosh. Oh, I never actually called this function. I never called init PC. Oh, yeah, that's my bad. I'm so dumb. What is wrong with me? I just wrote the function and then never called it. That's a classic. That's just a classic. Want to go for a course for C++? Holy shit, that's some bounce. That is some bounce. That is some bounce. Is it really all restitution? I feel like we had 0.5 restitution earlier and it didn't bounce that much. But I guess I was doing... I feel like you can learn without a course pretty simply. As you can see, it bounces with the terrain, but like it's really bouncy. If you have 0 restitution, it should not bounce at all, but it still is kind of bouncy. Okay. Your brain is kind of slow? Yeah. I don't know. I'd say like try programming out. I was kind of blessed with taking an AP computer science course in high school, and then I kind of figured it out from there. Okay, so the rotation isn't happening at all. The rotation isn't happening at all. Okay. Understood. All right, let's print. I regret this macro every day of my life. What are we working on again? It's just the physics. I want it so that this cube doesn't bounce so stupidly. You know, the idea is that you can just like push stuff around and it rotates and stuff. Like right now we can just like push the cube, right? But I want it so that the physics is proper, and the physics is definitely not proper right now. Yeah, the angular velocity is just so small, it looks like. Did I do this formula right? 0.5 times vec4, the angular velocity in 0, which is this, times this. Then you multiply it times the current rotation, you multiply it times dt. Oh, and then you add it. Uh-huh. And then you normalize it. Okay, let's try that. I have a dude that can ask them. I think that's just AI. Not to endorse AI. Everyone knows that I'm an AI hater, but I mean, that's kind of what it's there for, you know. For sure. Huh. We are getting angular velocity, it's just we aren't. I may have to try a different formula. I think that this formula is optional. Much easier to learn with AI. It is. It is. I don't like AI though because it's stealing my own goddamn job. Let's try removing dt out of it, because dt is already applied to the angular velocity update. Okay, that is crazy. That seems like some crazy shit right there. The interesting thing is that J is still 0 every time, actually. It's over 1, and that means that this is 0. But Vn isn't, I mean, it's small. Oh no, this is restitution. That's restitution. What am I talking about? This is J. And J is changing, so that's fine. Is there any instance you use AI when doing engine development / this? Yeah, sure. I mean, like, I don't like let it write code for me, but like when I need to understand something, then I definitely do ask it for help. But I mean, I disagree. It's kind of like a slippery slope, I think, with how people use it. Like, using it to write code is just a really, really bad idea, I think, just in general. It doesn't write good code, unfortunately. Well, fortunately, because, you know, at least gives us a chance to have a job, I guess. Maybe we're just supposed to give it more mass. Let's see what R is. Let's see what R in impulse is. Yeah, let's just print everything out. That'll give us an idea of what's happening. The R seems to be getting pretty big as it goes away from the center. Okay, so our center of mass at the beginning is, we translate it by the local matrix, and then we subtract the contact point from it. Let's see how this works out, I guess. I want to see P.A in current com. This is way beyond you. That's alright. It's one of those things that I'm not going to get right the first time. It's not like a very simple thing. Okay. Our current com moved from here to here to here. P.A might not be in world space. Let's find where we assign P.A from GJK. P.A might not be in world space. Let's see. It's in mesh. Let's see. P.A might. EPA. Okay, so when we assign P.A down here, we don't assign it. We don't assign it. Oh. Oh. Do I do it in GJK? Oh. Oh, I don't assign it. Oh. Oh. I only do it for the triangle meshes, but I never set up the... Oh, so we don't even have a contact point. No wonder. Okay, so how do we get it then? So smallest index equals I. The smallest index equals I here. Okay. So... Shit. Dear student, you must think outside of the code. You must control the engine. I'm a beginner in C, but still, why are you using C when all of the game engines use C++? What C gives except control? I don't see a real point to use object-oriented programming in general. Unless you're working for a company, maybe there's some argument, but it's pretty useless, it feels like. It is pretty useless. I want to... Okay, so... We do it based on the faces and not the actual support points, though. Do I do closest point on triangle? And then just return that point? Let's try it. Do I even have that? I don't have that function. That's not... closest point triangle. And then we just put in the... Okay, but what point are we testing against? Huh. I might have to look up how to do this. I know how to return a face, but I need the closest contact point. Furthest triangle of your simplex. Find the farthest triangle. Holy fucking shit, this is gonna be annoying. Find the farthest triangle. Return the triangle that is farthest from the origin. Calculate the projection of the origin in Minkowski's space onto this face. Derive the barycentric coordinates of this projected point on the triangle. Okay, that sounds really fucking complicated. That sounds really complicated and all these shit. I thought that I could just get the closest points. It comes up with a bunch of Final Fantasy videos too. Why the farthest triangle? Projection of the origin onto this face. We can project the point, is fine. Derive the barycentric coordinates of this projected point. I mean, that makes sense. Projection of the origin onto this face. In Minkowski space. That's weird because our origin is 0, 0, 0. Our origin is 0, 0, 0. Okay, we can try it. Okay, we can try it. The farthest triangle, and then project Minkowski space onto it. Okay. Alright, let's do it. Alright, so same thing as here. We're just going to loop through and find the farthest one. Is it farthest from origin? From origin. That is farthest from origin. Okay. Projection of the origin in Minkowski space onto this face. Do I just project onto the plane? Jarvis, answer my question. Okay, so yeah. You just project onto the plane. And then you do the barycentric test. Okay. So we have to find the furthest triangle from 0, 0. Holy fucking shit, this is complicated. Do I do centroid tests or do I do a test just like this? I think I do a test just like this. No, I think I do a centroid test. Okay, well, let's just do it, right? Let's just do all of the points. Haven't decided on a language to stick to, that's alright. I do recommend that you stick with one, though, because it'll make, you know, actually making things possible, you know? We're just going to do this. Okay, and then I may not be able to finish this today. This may be out of the scope now that I realize that this is going to be this complicated. I thought that we already had the contact points from EPA, but I don't think that we do. So vec3 length of the centroid because we're just going from the origin. Okay. If dist is greater than max dist, then we will do largest equals I, and then max dist equals dist, and now we have the furthest triangle from the origin on the polytope. Alright, peace out, Fifik. Okay. So now we have to project onto the plane, check the boundaries if it's inside of the triangle. Find the closest point to P and use that point instead. Get the first, you must clamp the projector. Why can't I do just closest point on triangle? Is it protecting from the origin? You must clamp the projection to that nearest edge or vertex of the triangle. This is so fucking complicated. I think what I'm just literally going to do is I'm just going to close this point on triangle it. And then if that doesn't work, then I have to fucking figure out some other way. I have to figure out some other way to do it. So we're just going to do... and then this is going to be the origin. Then I tried Rust, Gleam, and Scheme. Don't think my brain can do coding ever. You'd have to do pointers. Yeah, I mean that's what programming is. Do you not like programming? I don't know, like it's not this is like the fun part. C is fun, you know? Like why are you scared of pointers? This is like how a computer works, you know what I mean? You're too dumb? No, you just have to give it time. You know what I mean? Like, do you know how much time I've spent writing C? Like, guess how many hours? I don't even know how many hours. Like, thousands. Like, literally thousands. Like, just sitting in this room coding, you know? And not like watching videos in between or anything, just like straight up just raw coding, you know? Okay. So we have the closest point on the triangle. Now what do I find the barycentric coordinates of this on the triangle. And then what do I do with that? What am I multiplying the berries by? To determine, use the barycentric coordinates to map the point back to the world space vertices of convex holes. To find the contact. Ensure that they are normalized. Yeah, so I can find the barycentrics from this point. I can do that. That's fine. The fucked up part is that, like, I don't know how to find the contact point afterwards to the saved world space support points for both shapes. See, the fucked up part is, right? So we have our different support vertices, but how do I pick which one? Do I just pick any of them? Or the closest one to the center? Fuck. Yeah, that's the part that I don't get. Let's just get the berries. Let's get the berries, okay? Let's get the berries. The berries we can do. Compute 3D barycentric. This is what we need to do. Okay, so we're going to put in these points again. And then put in P. And then pass in our weights. It's just that I see a language and it looks cool, and then I try it, and then I see another language that looks cool, and it's like a loop. I mean, when I was young, I was the same way. Like with music, for example, like it was just like I would just take from here and there. But it's like the older I got, the more I like started like actually just like, you know, not doing the dopamine thing, and just like sitting here and just like spending my time getting good at something. And then I think it's like the only time I found happiness. You know what I mean? Like I don't think I've ever I went to school for music and for literature, right? I never understood them because I didn't spend the time. I didn't spend the time. I read a book here, a book there. You know, I wrote the music. I spent time doing that. But did I actually like sit here and like immerse myself for years of my life at something to get good at it, to understand it like deeply to the point where I was like, you know, I was in tune with it? No. And I was like, you know, I had a void in my chest the whole time. You know, it was only later in my life where I realized, you know, real true happiness comes from like dedicating yourself, you know, to one thing for a very long time, to the point where you like are completely at peace with it. You don't fight it anymore. You aren't confused with it in any sense, you know. With all my things before that, with, you know, art, you know, that I went to school with, I did the work, right? And I liked it, but I didn't, you know, in the downtime, I was making coffee, I was going to shows, I was hanging out, I was having a beer, I was doing this, I was doing that. You know, I did the work and I read, you know, I was just like everybody else. But did I actually like sit there with all my time and just give myself to one thing? No, you know. And so I never, I think I was missing out on that for great point, you know, part of my life. And I think that that's also just a problem that most people have. I don't think most people, you know, I think probably a gift of my like retreat from society in general, and like giving up all my relationships with everybody, is kind of the fact that I found happiness in, you know, in that, you know, but it was like a forceful thing, right? But I think that's probably, you know, something that that's important, you know. Okay, so what's our number of support points? Supports, it's supports.count. Is coffee the only thing keeping me alive? What do you mean? Like, do I eat? Is that what you're saying? I do eat. Not like that much, but okay. So I need to cast the Vec at the end. Is it support vertex? Is that what I called it? Is it like this whole thing that is keeping my heart pumping blood? Not really. I do eat. Like when I take breaks, I eat. Let's ask Jarvis. Which support points do I choose? You must use the... You pull the support points... Oh, from the first ones, from the initial ones. Aha. Okay. And then we multiply them by the... They will always be point A, B, C. But I have 4 points, not 3 points. Don't fucking... Dude, don't fucking retype when I type polytope to polygon. I'm not that stupid. Find the closest one to origin, edit, and yeah. Final triangle. The final triangle. What the... How do I find the final triangle? I don't know. Last bit of GPL code? I have no clue what that means. It might be this one. It might be this one. I think it's this one. The smallest index I. Okay, actually, you do want this. You also want to cast for the points, though. You want to cast for everything. Okay, so this is the smallest index face, and we're supposed to multiply the vertices by these barycentric coordinates to get it. How do I do this again? I have this in a different file. In my light map, I do something like this. Yeah, it's basically this, but in 3D. BSD, but you don't want to give up on Nyx? Well, then why don't you dual boot? Okay. So that is our contact point? You're telling me that that's our contact point. I'm going to be so happy if that's our contact point. Jesus. I really have been going through it. I really have been going through it. Oh. Oh. There may be a slight divide by 0 or something somewhere. Oh, I free them I free them. Whoops. C is unsafe. Dual booting is for wuss. I have dual booting on every machine. Are we fucking serious? We can't be serious. We're not serious. The fuck is the problem? Yeah, I might have to just do the lighting probes. This is ridiculous. Face normal. Where? 1391? Why? Why? This is exactly how I iterated here. How does this go out of balance? This doesn't make sense. Oh, I don't, yeah, that's why. I don't actually, recast after the vector expands. Yeah, I don't think that the PA is in world space. So we may not have to actually translate anything at all. But it's very confusing why this doesn't at least rotate at all. Let's get rid of DT for now. That's more like it. The angular velocity still doesn't do anything. Let's try the getting rid of the normalization. I think it's rotating now. No, maybe not. Let's see what's printing out here. Yeah, restitution now helps it. I think that the DT thing was fucking with it. I think DT is a large value in the engine. I think that's a problem. Okay. That seems better. Yeah, multiplying it by the current rotation apparently doesn't really seem to make it good. Doesn't really seem to make it good. When I initialize a new one, I start it like that. But let's just try I think at 0. I don't think that I think you're supposed to start it with a 1 in the W component. It is quite laggy because of all the printouts. Yeah, it doesn't seem to rotate when you multiply it times the rotation. See the formula for it again? Yeah, it just doesn't rotate. Maybe I should just be happy with this for now. Then we can figure it out later. Let's see the current center of mass and the PA. Negative 4. -4. Yeah, I have no way to verify if that PA is correct, if the contact point is correct. I have no way. Oh, also, we don't have the version of J that includes rotation. Yeah, I've got no clue. Maybe I should ask Jarvis about this. It should be the same point every time, the P.A. It's not. Yeah, I mean that seems wrong then. The point should be the same if it's always falling on the same place. -1. And what is the bounding box? Let's print the AABB of the Do I not have the mesh? Let's just get the mesh real quick. Let's just print the AABB so that we can see what it's like. Min is -1.7. And the max is 1. So it's basically -1.5 to... What do I use for debugging? Usually GDB. Okay, so that contact point can't be correct. That contact point cannot be correct. No, it definitely can't be correct. We can probably cheat the contact point for now and just have it be one of the... How old am I? 25. Really wanted to write my engine in C, but I went with C++. That is big enough. I can't rewrite or transform it easily. Yeah. Yeah, I mean, that's just object-oriented programming paradigms, you know. It just kind of sucks, right? Let's just try without the barycentric stuff. Let's just try just straight up 1 point and then see what it's like. Does GDB handle GPU side exceptions? No. No. That's the unfortunate thing. So you do have to kind of work with the tools that OpenGL gives you, which aren't many. There aren't many of them. Yeah, this can't be a valid contact point. Unless it's in world space. But I don't think that it is. Actually, let's just check that by pushing it around. Should be very easy to test. Yeah, it's not in world space. It's definitely not in world space. I only chose C++ because I thought that memory would take a ton of time. Yeah. Use Visual Studio, which is perfect. Is it also... It's very good. Yeah, Visual Studio is pretty good, yeah. It's got a good debugger, too. I just prefer... I prefer the simplicity of just an editor. Maybe instead of the point, I use the support point. Maybe I try that. Is this V, A, B, or P? I think P is the point, but A might be the actual point. Can't seriously work on your engine? Yeah, I get that. I don't really, personally agree with that, but that is what it is. Learning the basics of C++, when should I start learning OpenGL? Whenever you want to. I don't think OpenGL is hard. It's the rest of it that's hard, like EPA. Can you make a game about my school and my stupid teachers? I might be able to. I don't know if that's what I'm gonna do. Support diff should give me s.a. Why is s.a permanently 0? Let's try passing an SB. Why is it 0? B is also 0. Huh, I guess for the closest point, it's always going to be... Oh, also, SV smallest index is probably not the correct way. Oh, it's probably... Oh, you probably have to index it by that. By this. By the same thing as the... How long have I been learning C? For a few years, probably 2 years. No, it's still a 0. Huh. I guess it makes sense since it's the closest. But yeah. I mean, shouldn't it be different for the furthest face, at least? Unless it's something that I don't understand, which there might be. This is quite complicated. Huh. Huh. That is strange. OpenGL is willingly making itself hard. Be state-based. Where everything is hidden in OpenGL. I guess so. I mean, it makes sense why other people use Vulkan. I just can't because I don't have a good computer. My computer does not support Vulkan. Yeah, I may have to leave this for another day. I'm kind of lost with what to do. Here. VP is obviously not going to, is just going to give us a point, but it's not. It also just gives us 0 as well. Well, I mean, that makes sense because the support points give us the distance to the origin, or in to the origin. So I need to find a way to let me try to how to translate Minkowski EPA support points to world space. There's probably some specific thing that I have to do. Project the origin onto the closest triangle. Now it says the closest triangle. So which one is it? Because if we want to do the closest triangle, then we can do smallest index. And then this becomes just chord again. Yeah, this is still 0. Like the graphics, it's just normals. You can see the light map like this. I just have it for debug purposes now, since this just doesn't have a texture on it. So this is what it's supposed to kind of look like. What am I supposed to be multiplying by the barycentric? V equals A minus B. To deduce the actual contact points. Okay. Point on object A when you should cast the original world space support points when generating the triangle. Okay, I have that. I have this here. And then it says, so it's saying to do basically the oh, for this, so it's actually SV dot A. Okay, let's try that. Yeah, seems not to work, to be honest. And also sometimes, because the barycentric sometimes go out of the face, so that was the style. Thanks. It's just debug. Yeah, I think I might just move on from this right now, because this is kind of stressing me out. This is you know what it's telling me to do, right? Is to take the closest point on the triangle that is the closest to us, and then compute barycentric chords from it, which we're doing. And then after that, you take the support vertices from that face, and then multiply them, and then multiply them times the barycentric weights, and then this is our final position. But it's not working. It's giving us mostly 0, 0, 0 every time. So who knows? Who knows? I think I'm just gonna work on the probes for now, because I might come back to this later. But what am I trying to achieve? I'm trying to achieve I need the ball to have just more accurate physics and angular velocity. So what this is, what this p.a value is, it's a support point. It's the point of contact between the two bodies, right? It should be generated from our physics solver that I'm working with, but I don't know how to get it yet. Anyway, basically that point is important because I need to find the distance between that and the center of mass to rotate it, right? Because if it's hit on at a certain point, it needs to rotate in a certain way. So that's what this formula is doing, and the formula works. It's just that we're not getting the point correctly. The point is coming back as 0, 0, 0. Which, it kind of sucks that my EPA and my GJK work logically, and they work at determining, exactly when a collision happens. I just don't have the math ready to get the information back from it. So that's the problem. But for right now, I'm just going to go and try and work on the probe lighting so that we can get some dynamic lighting happening in not SSBO. So that's what I'm going to work on now. I'm going to make it a texture so we can work on that. It's not very complicated. Really what you want is you want a probe texture with 9 probe textures for each spherical harmonic. I don't know if we're going to start with all 9. I think we're just going to start with 1. And so we'll probably just call probe text 0. Be that 1. It's also going to be complicated to bind all of them. I don't know. I've never bound that many raw 3D textures before. I don't know if there's a problem there, but we'll figure it out later. All right. The probes are going to be exciting because then we can push the box around and it'll change color and stuff. So that's exciting. So we want to get rid of the SSBO stuff because that was incorrect. Apparently we're supposed to do a 3D texture. I'm going to go into init and go and overwrite the SSBO stuff. The SSBO should be over there, actually. But, yeah, we're just going to get rid of it. I mean, technically, you do want the uniforms, but we're not going to put the uniforms in an SSBO. We're just not going to do that. That's stupid. Okay, so let's get rid of this. Let's get rid of it from the other shader. Okay. I was interpolating them internally in the SSBO, but you just bake them into a 3D texture and the interpolation happens on its own. So that's what happens. That's what happens. So instead of on init setting up and genning a 3D texture, we're just going to gen it when we bake our light map. That's what we're going to do. So, how do we do this? We're just going to do a 3D texture here with probe text, right? And it's going to be 3D. And it's going to be 32F for now. And the width and the height is what we have to deduce here. So let's do the math for the width and the height, right? So we have our scene ABB. And we want to get world width is going to equal the CLF scene ABB dot let's start very simple with this because it's going to be a lot of math to do this. So Let's do a world min. World min. And then let's just do this. We're doing this because we need to determine how big the world is when we when we bake our lighting, so that we know how big the texture needs to be. Okay. We also want a few globals here, and we're gonna just neatly just put it into globals since we have a struct here. All right, we're going to have I'm not sure if the probe spacing can even be a float with how the math is going to work out. Yeah, it can. It can. It's just weird. Yeah, I think that's all we need. Okay. Let's just do that. Actually, this should be floorf. There we go. So now we're just finding the bounds. Okay. And then later when we write this to binary, this is just, we're just going to read these things in. Now to find the texture size, all we have to do is divide it by the spacing. Yes. So to do this, probe text size is going to equal the world size divided by the spacing. Okay, wonderful. I have no clue if I'm doing this fucking correctly. I have like zero clue. Okay. You might want to add a 1 or something like this. I'm not sure. I'm not sure. Yeah, I did say this up here. I did add a 1. I mean, the CLF should possibly be enough, but I'm not sure. Just add the 1, just add the 1. Okay. So this is what we will, the world size dot x, world size dot y. I don't know what the, I think that it's fine. No alpha. And we're gonna pass in the raw data, which we will store as a buffer here. We're just gonna calc this to the world size dot x times world size dot y times world size dot z. It's gonna get mad and we're gonna have to cast it to an int. And this is gonna be a size of vec3. And then that's what we're going to give here. And then we're just going to free probes at the end. Excellent. We also have to set these to texture 3D, of course. I think you also need wrap R. Okay, so far so good. I think everything so far is pretty reasonable. Pretty reasonable. Instead of doing this, we want to start our probe pause at world min. At world min. And instead of going probe amount Z, probe amount Y, probe amount X, we'll go probe text size. You know, I'm calling, now that no one's here, I'm calling that the Odyssey is going to suck. You know, hot take maybe, but I didn't like Oppenheimer. Sorry, I didn't. I really didn't. Wasn't a big fan. That's alright though. hopefully this is going to be correct. We iterate z last, which, you know, it matches our world space coords that we're doing. All we have to do is, instead of doing this, by the way, get rid of probe data. It might actually make sense to store the probe data on the CPU, but for now it's just we need to completely refactor it. We can comment that out. Okay. So what we're just going to do is we are indexing into probes via the probe count. And we're just actually going to store the raw RGB. And there we go. I think we did it. Okay, now all of this spherical harmonic stuff we don't know yet, but let's just keep moving onwards with our lives and just, you know, let's just keep moving onwards with our lives, you know. Okay. First thing we have to change in render, we're gonna have to upload this texture first of all. Texture 3D, probe text 0, and this will be called probe text 2. Excellent. Okay, now we have to do all the uniforms. Didn't I put them somewhere? I put them here. Okay, so we need to do them in this order. 3 different uniforms. We're gonna do probe spacing, and this is gonna be probe spacing. And then we need to do the other things that we did, which was world min and world size. I believe that that's what we need. Actually, we may actually need the fucking the probe text size. All right, let's add that. Maybe I didn't need to actually floor the world min. And I could have kept it, but whatever. We won't worry about it. We won't worry about it, I think. I think we won't worry about it. Okay. This could get hairy, though. Could get hairy. What did I call these? Probe origin. Okay, those are the uniforms. We just have to make sure that this is correct. Okay. Okay. So, to get the coordinate, it should just be this. It should just be this according to Jarvis last night. We need to take in vpos. That one's important. The fuck was that? Fuck was that noise? Just scared the shit out of me. I don't know what that was. Okay, focus. Okay, we can get rid of the probe thing. We can get rid of all of this. So do I just sample the texture with this? Okay, let's try it. Let's try it. Probably going to get yelled at by GLSL in a second. Okay, we have no light. We have no light. We have no light. And our shader compiled, so. Okay, let's debug it then. Probe grid size, probe origin. Let's just make sure that the names are correct. Probe text. Probe spacing. Probe origin. Probe grid size. Let's make sure that we're assigning all of them here. Oh, I don't set I don't actually set it to the global here. Okay. Try a smaller thing. Let's try the classic test of just testing like just a vec3 of 1 1 1. There a mirror. Okay. So we have one little line. Okay, so let's do some testing here. That is every probe getting it. So that means that we definitely aren't indexing it correctly, 100%. This isn't world size, this is probe text size. Let's see now. Oh my gosh. Okay. I like it so far. Okay, now there's nothing. Now I don't see anything. Okay. Okay, so we are sampling probes, they just aren't. Okay. Think about the math here. Pos minus probe origin over the probe spacing. Divided by the spacing. That should be correct. Oh, we didn't allocate it to the right thing. Okay, nothing. Let's try not dividing by the probe spacing. Let's try not this. Let's try doing this. Hold on a second. Are you supposed to divide it by the probe grid size? I think that that's what you're supposed to do. Okay, there we go. There we go. Yeah, sorry it took me so long to figure that out. I was just overthinking it, really. There wasn't really a bug, I just wasn't dividing by the right thing. Still not great. Hold on, let me clean my glasses. I smudged them in frustration. Just kidding. Wow, that looks like shit. Wow, that looks absolutely like ass. Oh, also, you know what I just realized? That this vpos needs to take in the translated position, of course. So I have to. See if that does it. Okay. Why is it so dark, though? Thought that it's supposed to be linearly interpolating between them, but it's really not. Huh. I think the position is correct now. The part that isn't is, I think, the baking. Let me try not dotting with the dirt to find it. Wouldn't it be easier to just use proper debugging tools? To do what? To do what exactly? To do what? Okay, so that was the problem. It is sampling the light behind it, though. There is still black. There's still black stuff. I'm gonna assume that it's just not sampling at all, the black stuff. Oh, but no, yeah, it has to be probes. Because it has to be individual probes. Because we tried the flat. We tried the flat lighting before, and it didn't. That black doesn't appear. So it has to be the baking, right? Yeah. And if I don't divide it, then it's fine. I guess that there's a possibility that a probe gets 0 hits. Yeah. I don't have that. Right now I'm just doing a random distribution also, so it may have to do with that. That my distribution is completely random. It's also a thing. How many rays am I doing? 128 is a lot. 128 is a significant amount of rays, for sure. Okay, that looks decent, to be honest. That doesn't even look half bad. I mean, it's not really that great either, but I don't really have the spherical harmonics or whatever yet. I wonder if I try a lower spacing if it'll actually make things better, because what I'm noticing now is that the top of the mesh is getting cut off. I already have a really low spacing actually. Like if I go any lower than, oh wait, no, that's the other way around. A lower spacing means higher density. Yeah, this is gonna take longer to bake now. Okay, the math might get fucked up when it's less than 1. I didn't really consider that. Yeah, so now it's actually better with a lower density. I'm not like exactly thrilled with it, not gonna lie. Especially since the light bleeds through. That's the problem, really, is that the light bleeds through. That's the whole reason we have this dot the normal with the direction thing. Is for that exact reason. But apparently it's giving us problems with these directions. Oh, actually no, it's fine now. But it still does bleed through. I've got to get rid of this P.A printout. It's slowing us down quite a bit. Let's go to that printout and get rid of it. Okay. It'd be easier to just use proper debugging tools. Interesting. Interesting. Okay. Yeah, I guess we were dividing by 0 at some point there. And that was the problem why we were getting those holes. Should actually, like, before we move on here, we should make sure that we are, oh, I don't divide by 0 here. I have a gate, so that was only my stupidity when I implemented this one specific thing. Okay. So should we move on to spherical harmonics? Is that what we need to do now? I'm not really happy with how it looks, I'm not gonna lie. But maybe this is the whole reason you do the harmonics thing. I don't really know. Yeah, I think probably lighting probes inside of an area that's not enclosed is kind of a challenge, no? Let me look this up. So I think I'm just doing indirect right now, and I'm not supposed to only do indirect. I think I'm supposed to do direct as well. I think that that's the problem. That's what I'm missing. Because right now I just have indirect sampling. I don't actually do direct lighting, which I don't know why I thought that this was how you're supposed to do it. But obviously you also need to do direct lighting. And so up here you just process it as direct lighting beforehand. I think this is the way. You just do the probe pause. The thing is, we don't have a normal. We may have to make a different solve light source, a solve light source that doesn't use a normal. Okay, so yeah, it's just how I expected. You have to take in the direction vectors of each light, right? And then do the spherical harmonics on them. You can't just solve it as a regular diffuse light source because you don't have a normal, of course. So we have to write a separate function to do it. And that's going to do this. That's going to do this for each incoming light source. I do wonder if we need to do anything based on distance, though. Like, I'm going to assume that that part we need to stay the same. Like, we obviously need to divide by D2 times light intensity. That's probably what we need to do. Alright, let's do it. Let's try it. Let's try it out. Let's make a solve. Oh, what the fuck? Solve light source probe. So it's not going to take in a normal, a local matrix, anything. So there's no mod dir. There's none of that. Inverse pause is just the pause. Just pause, pause. So we still do the distance calcs. That makes sense, right? That guy, that really, you know, it's kind of tilting to look over at my other screen and just see, you know, wouldn't it be easier to just use proper debugging tools? Like, in what fucking world is RenderDoc going to help me place my lighting probes? Can you fucking explain that to me? I mean, like, what are you, like, I don't know. That just kind of tilts the fuck out of me. Okay, so we're just gonna go based on the distance and the light intensity. And so we're not worrying about the harmonics yet. I just want to get this correct. Okay. It's fine. It's just, you know, it is, you know. Okay. What did I call this? What did I just call this function? Oh. Okay, let's see if that does anything different. I mean, we can actually just straight up get rid of the indirect stuff and just straight up just only bake the direct lighting. Okay, that's really fucking bright, isn't it? That's really fucking bright. Is it not determining occlusion for anything? Let me match it up with this. So this inverse pause is just the inverse matrix. So that should be fine to just be this. The shadow dir, I already put in twice here. It's just the light direction. And then the inverse dir is just 1 over it. So that's all. That all should be completely fine. Hold on. The dot of the normal in L. Let's just scale it back by some value. Let's just go 0.5. I don't know. Because it's evaluating all of the probes as facing towards the light. It's still just super bright. I mean, how low does this have to get for it to? Yeah, even this is just okay. Yeah. Huh. How about let's just solve it for only the third light. How about that? Let's just go one light at a time. This is just black. Which light is the big directional light? It's the third one. It's the third one. So then it's some other light that it's one of the other ones then that's making it super bright. Huh. Yeah, I'd argue that and the probe pause is definitely changing because we know that it was changing from before. I guess that for the point lights, the D2 I guess is crazy, huh? Like, let's test the... Let's see the D2 at each point, and let's test the probe position along with it. How about that? The probe position is moving as expected. The D2 is just fucking massive. Yeah, I wonder why, because our light intensity is super high, but I really wonder why it's specifically so high in the case of this. Really, what we can do is just take light intensity off of it, and then just this should give us like a regular result. But I guess I'm gonna have to figure out why. Probably when the texels, the UV light map texels. Oh no, this is still just bright white. Oh, because D2 is massive. Oh, right, because you're dividing by D2. What the fuck is wrong with me? Oh my gosh, I'm just doing the wrong thing. You're supposed to put, you're supposed to put 1 over D2, probably. That's probably what you're supposed to do. Okay, there we go. There we go. That's more reasonable. Yeah, I don't know what you put over it for something like this. But yeah, I was doing the opposite. Because I didn't have anything to put over D2, so I just scaled it. Usually it's like 0.5f. Usually it's just 0.5f. Because that would be like in between 0 and 1 for the normal. Okay, so there we go. The box disappearing is probably a physics thing. The dark spots are kind of worrying, not gonna lie. The dark spots are kind of, because the top should just be dark. The top should be dark. If I had to guess, it's just not. The shadow rays probably aren't working to determine occlusion. That's why it's light on the top. Now once again, if I go over there and I take the normal checking off of it. Oh, right, because we don't pass in a normal here. Oh no, but we pass in a dir. Let me see. If I get rid of this, does it occlude? It does. It does. That's kind of annoying. I'm guessing that it's because there's probes inside of the geometry. We could just pass in a Boolean that makes us do this check. Because there's definitely cases where we don't want to do the check. But yeah, that would be why that's happening. But then again, we don't get the red light with the regular. We don't get the red light, which is a problem. We're supposed to get the red light as well. And without this, we don't get the red light. So that's definitely something as well. Now, yeah, I think that this is definitely the way. It might be that the probes. That there either aren't enough probes or that there's too many, or something like that, because there's obviously, it's seeing through the ground, so it's interpolating with the probes that are on the other side, I think. Yeah, I don't know. This might be something that I have to check on later, and I should just do the harmonics now. It's not even that it's darker on the top. I'm gonna guess it's because there's probes in the middle that are getting it. Yeah. you probably want this, because if a probe is inside of geometry and it's seeing out, you still want it to hit it, because you want it to go to 0. Yeah, this is something that I might just like need to play with until I'm satisfied. For now, what I'll do is I'll just pass in a boolean to these functions just to see, you know, if it should check the normal, and I'll just move on for now. I'm guessing that, you know, with this, the lights are just gonna look perfect without the shadow rays. Then yeah, it looks fine. Yeah, I'm just gonna pass a boolean in, even though it's like a ridiculous amount of it's a ridiculous amount of fucking arguments now. What I should do is I should just pass a struct through with all of this data, but I'll do that when I want to. It also sucks to have this branch at the end here. Luckily, I only call this at three points, and I call it inside of here. Okay. Now this should do the equivalent of what? Oh, it's in the header, it's mad. Now this should give us the equivalent of what we did last time, which is the black on the top. You know what, let's make it so that the cube doesn't fall through the ground anymore. Okay, why does it fall through the ground? I just want to be able to push it around and see the light and see if it's red over there. Okay. It is red. It's just that it doesn't sample that probe, but it is red here. It just doesn't sample that. It just doesn't show that it's red. Maybe that's where the harmonics need to come through. But I could just like direct equals 0, 0, 0, and then we'll just be adding on to direct, and then the RGB will be the indirect, and then vec3 add direct RGB. Okay. Am I caching 3D lighting data? Yeah, it's just probes. 12 of 11 light map.c. Yeah, so basically what's happening is that I have a UV light map that is baked, and I'm trying to cache it into probes that go on top. So that when you push around the cube or whatever, it changes color. That's the whole point. The weird thing is that it gets like red light over there where it's not really supposed to. I think it's because the randomized distribution that I have going on here. You're not supposed to do that. But I don't know how to do it another way. I have the calculate bounce function, but this happens maybe it's fine. I think that it happens over one axis and not over the entire thing. But we can try it. Yeah, it doesn't go over an entire sphere, so that's kind of the problem. This would be probe count to hash it. Still trying to figure out SSBOs? Yeah, SSBOs are cool because you can just basically put anything in them and... Oh, this looks better. You can basically put anything in them and you're kind of happy. This does look better, but I mean, at the same time, I'm sure with enough rays, like if you just send like a lot of rays for this, like if you go to like 300 rays, I mean, that's a ridiculous amount of rays, but just to see, yeah, it still is kind of not my favorite. The problem is I'm pretty sure that there are probed inside of this thing. Huh. Yeah, I'm pretty sure that the whole indirect thing you're not supposed to do, but yeah. Or at least the indirect stuff is probably less important than the direct lighting. It should be linearly interpolating, but I feel like it's kind of rough. Like it is going to turn red there, so that's correct. Let's see how it would look averaged with our regular light map. So let's just go light times light probe. Well, you can't actually, because let's go light plus. Yeah, that doesn't look too bad. $128 rays. Yeah, I mean, in terms of like baking lighting, it's not like that ridiculous. Are you using vertex lighting, or is that how probe lighting looks? I think it just looks rough right now, because there isn't any spherical harmonics on it. With the textures on it, it's obviously going to look a bit better. Yeah, I'm pretty happy with it. That's alright. It's not like the craziest thing in the world. Now is the point where we should do the spherical harmonics, though. I wish that there was a way that we could... can I do a sampler 3D text array? Let me see if I can do that. OpenGL... I've never done that before. 3D text array. Does this exist? 2D texture array. No, you misunderstand. I want a... No. No, I need an OpenGL text array of 3D textures. Like, I don't want an array of 2D textures. Okay, no. There is no GL texture 3D array. Okay, that's all I wanted to hear. That's all I needed from you. Okay, so we need to make all of them separate. We need to have 9 of these, which you hate to see. But that's alright. We can put them in an array. Like this. And then that's just what's going to be. How that's going to happen. The reason why we need 9 of these is because there's 9 harmonics. Is it forward rendering? Yeah, you could call it forward rendering. We haven't really, decided on if there's gonna be a G buffer or what, but we can call it forward rendering, sure. At least for right now. I typically don't really agree with the whole deferred thing, because I don't really, in my kind of style, I don't really like do a lot of PBR stuff, and deferred is kind of just overall can get slow, but okay. So probe text 9. We're just gonna make a function that does this so that we don't have to yeah. All it's going to take in is that. And that's exactly what we're going to do here. We're going to do It's kind of beefy. You need a lot of G buffer and lots of lights. Yeah, exactly, exactly. And especially if you're already baking a lot of lights, you know, it's like, you know, you can really get away with not having to do it. It's just it's just like not kind on older drivers, deferred lighting. It's just really not kind on things that require a lot of like very little driver things going on. Okay. So instead of just adding direct here, when we solve light source probe, we want to pass in here the probes. And now we're not going to be doing this. We're going to solve it directly. So we'll take in a vec3 pointer probes 9. We should really just have this as a define, but you know, this is okay. Okay. So down here, after we determine occlusion, we want to do the harmonics. And I kept the harmonic math here. And it looks scary, but it's not that scary. Okay. The question is, which does it need, the incoming direction or the outgoing direction? I think I'm just going to use L. I'm going to take in the probe index. Probes 0. Probe index. And we are going to scale this we're going to scale RGB by that. Y1, we're going to scale it by that and then multiply this times the Z component of L.Z. Okay. Or wait, hold on a second. No, it's the Y. It's the Y. Then 2 is the same thing versus the Z. And then you do the X. And then it is X times Y. With 1.092548. These are all like square roots and shit. That it's just, this is the not square root version of it. So that we don't have to do like square root of 60 or whatever. Okay. 0.315392. Okay, times 3 times z times z minus 1. Okay, almost done. Now it's 1.092548 times L dot x times L dot z and then we do the squares at the end. 0.546274 546,274 L dot x times L dot x minus L dot y times L dot y. Okay. All right. Okay. So that's that. Now we have to generate the texture. Protex I globals dot okay. Okay. And now we just bind all of them. Okay, so how do we bind all of them? How do we bind all of them? That's a good question. You can just do plus, right? You can just do plus, right? Just for now, we're just gonna do it like this. There's probably, I have to look up a better way of doing it, but yeah. Oh shit, but we need a name for each of them. Alright, we're not gonna do any string bullshit. We're not gonna do any string bullshit right now. We're just gonna do it manually. Sorry for everybody that wanted me to do the string bullshit right now. That's not happening. That's just not happening. We're just not doing the string bullshit. Is this gonna be worth it? I can already feel the regret. What am I getting myself into with this? I'm not updating the names. Shader class. I don't think that that's going to help us here. Unfortunately. I just don't think that that's going to help us here. In my last engine, trust me, I had an insane amount of abstractions over everything. But with this, it's not really going to help us. Unfortunately. Okay. So that's 7. And we at 10. Okay. Okay. And we'll just make a function that just binds this for whatever shader when we need it. But for now, we're just going to hard code it because that's just a ridiculous amount of textures. Oh yeah, we didn't actually do the math with it yet. Okay. So oh my god, we need to sample all 9 3D textures. What the fuck is this? Wait, what a disaster. Oh my god. This is so expensive. What the fuck? I just clocked it in my head what's going on right now. Oh my god, we're about to do that 9 times per pixel? Are we fucking serious? Jesus. Okay, whatever. Let's just copy over the math. I deleted this one because I was being stupid. We have to multiply it on the other side. Wait, but how do I... Do I have to find the direction between... Hold on, let me Google this. How to multiply by spherical harmonics in the shader. What is n? Oh, it's the normal. Oh, it's literally just the normal. Okay, that's fine. That's completely fine. I make my old engine in C. When did I just start fresh? Yes. The first like 400 hours of streams on this channel was my engine in C. At the end of it, I just knew that I could do it a lot better. And this time I actually want to make something with it. So, my last engine, I made an insane amount of abstractions over everything with its own material, render grouping system, batching, like an insane amount of stuff. And then I realized, oh, when you make an engine this general, it kind of makes it unpleasant to work with. And so my kind of goal with this new engine is to make something that's not as general, if that makes sense. Okay. So, okay. I'm thinking that we only do this for certain assets. That's what I'm thinking. I think we literally just pass a flag with the asset that determines if we're going to do this, because this is very expensive, what we're doing here. Like, almost hilariously expensive. Okay, so we have to write this on the other way, but it is cool. Like, there's a certain cool factor to having the probes. I always wanted to do probes, just because it's fucking cool. So I think that there's like just a certain cool factor to it that I like. Do I even have vnormal? I do. I'm just gonna store it because I'm lazy. Oh boy, this is it's a whole lot of writing we're doing today. Man, I wish that we got the physics stuff working. I'm gonna have to keep doing research. I keep, you know, every day after stream I do like reading so that I can keep making progress in the Millington book, and then I like jot notes down, but I'm not gonna like straight up just like read it during stream, you know. So I tend to figure that stuff out after stream with like the actual like preparing stuff, and then write the code during stream. Okay, so this one's the funny one. That one's the funny one. The funny thing is that harmonics like this is how sound works, you know. Apparently it has to do something with sound that they discovered how to render using like the same math that's in sound. But I remember in the music theory, you know, class where they were talking about you know, harmonics, and then they my teacher went over to the piano and then doom boom boom, you know, did all the harmonics just from memory because she was fucking cracked. Yeah, she was really good. That was like one of my favorite classes because our test was to literally let me just make sure that I don't fuck this up, and then, you know, our tests were to literally like sing intervals over each other, and so the partner would sing like a C, and then we had to, you know, sing like a major seventh or whatever and shit. That was a lot of fun. It also is kind of fucked up though, because some people just were tone deaf and they just you know, I was kind of cracked at it though. I would practice a lot actually on singing the intervals on my own because I enjoyed it. Yeah, I think now you just add them up. No, do we have to divide by 9, or is it just fine? if using lighting probes, do I divide? Explain this to me, Google AI overview. I do not divide. The math is pre-baked. Okay. Well, then we don't divide. Okay. Now, theoretically, if I did everything right, we should be happy. We should be happy. Okay, we didn't do things right because we have some errors. We need the probe count. Okay. And then this is going into, this doesn't go into anything. Oh yeah, before I forget, remember to fucking call the generate probe texture with probes. Free probes, free 0, less than h8 as max, I plus plus. Okay. Z, undeclared identifier. That is an undeclared identifier, you're so right. Honestly, if this doesn't look like the greatest thing I've ever seen, then I'm going to be pissed off. And we seg faulted, so let's see what GDB says. GDB doesn't say anything. It just, you know, we get through it. But we don't have a probe texture. We are also incredibly slow, by the way. This is just very slow. So why did we seg fault? I think it's sampling all those 3D textures that's killing us. Alright, let's just see what the probe light itself is. Or are we just... We just seg fault. The probe... Where's the probe count? Where's this probe count? Print out from? Oh, print out from here. Oh, fuck. Yeah, holy fuck, we are slow. We are so slow. And we don't have anything in it. Oh wait, what the hell? I'm supposed to be sampling by text local. Oh wow, that looks kind of good. That looks really good actually. Okay. Okay, the red light doesn't appear to happen here. It's just the green light. The green light looks pretty good. The green light looks really good. But why doesn't the other lights happen? Also, how do I get it to not run like shit? That's gonna be the problem. That's gonna be the problem. Nine texture samples is kind of crazy, not gonna lie. Not gonna lie. Okay, but I don't think that I'm supposed to do this. I don't think so. No, I think that it's working. It's just the red light doesn't appear. And the blue light doesn't appear. Let's not do occlusion. Let's try getting rid of occlusion. Yeah, it's so cool because the direction of the light matters. But I wonder if we're supposed to negate L. Let's try negating L. Yeah, that didn't seem to work. Let's see the formula. Let's make sure that the formula is correct. Oh, I'm supposed to be adding to it. All right, that's kind of cursed, but that should do it. Wait, I think that it's in the wrong place. Gosh, it's so slow. Yeah. Let's try negating now. It's cool. It is slow. It is very slow. I mean, what we could do is we could just literally, it's the sampling of all the textures that's slow. What we could do is we could literally just pass in a flag per mesh. That like if we just want to test what it's like right now. So just to see, just to ballpark what the exact, because for static meshes we just won't do it. But I want to see if this is just a GPU thing or if it's the binding of the textures that's the problem or something like this. I don't know. Let's just see. Let's just skip it on the static mesh, and then only do it on the cube. I think I did it the wrong way around. Yeah, there we go. So on just this mesh with the lower amount of vertices. I'm not sure if I really like it. I mean, I think the math works. It's just super fucking expensive for what it is. You know what I mean? It's so expensive. It's like ridiculous. Also, it doesn't really match up with how the floor is, because I'm just doing this. Like, obviously my baking says that the floor should be, like, I think the directions are correct. But it's just so expensive. I mean, my computer just simply can't do it. Yeah, very cool, but my computer can't do it. I think that's my decision here. Which is like, when I get up close to it, it's like so bad. Yeah, I think that we might just keep probes, but only for RGB. My computer can't do this. I think that's what it is. And I don't think that you can push it below because then the math gets fucked up. Oh no, you can. Yeah, I think if you really want to do this, then you have to compute the spherical harmonics for what's underneath it. I wonder if you could just do this in the vertex shader instead of the frag shader. I wonder if that's possible. I mean, it probably won't look great, but I mean, maybe you could get away with it better. Let's try it. Let's try it because I don't want to give up on this, but I also know my limitations. So let's try it. Fuck off. Just move all the uniforms over. Let's give it a shot. Okay. So we'll just have all right, let's try to do it per frag. In the frag. Okay, that's much more doable. Now it's not lagging. It's not lagging anymore. Yeah, doing it per vertex is probably fine. And it looks like pretty good. It looks pretty fine. It definitely is like something where you have to make a compromise, you know? Just have to make the compromise. Okay, so the ground doesn't get light. I think you need indirect. But then we need to solve it. But then we need to solve it like we solve indirect, which is kind of ridiculously difficult to do with the spherical harmonic shit. When we get a hit, we should just put it through a function that does this. Yeah, we should just have a function that does this. Okay, so we just made a function that does that, and now when we do the indirect stuff, all we have to do is solve sh probes probe count lighting, and the dir will either be, so is it, I think it's the opposite of the dir that we go outwards from. So the negative dir for that. Now we definitely want to do less rays for this, because this is going to be expensive. Yo, what's up, Luca? Okay. So I feel like we got nothing out of that. So I feel like that was just a complete fucking waste of time. If I just do the indirect light. Project looking good, thank you. Thank you. I'm trying to work on the physics today, but kind of failed. Yeah, as I thought, the fucking indirect just doesn't. Let's try a random direction again. And let's visualize it differently. Let's actually just like straight up visualize just the well, now I can't visualize both because I have this, I did it per use probe, so just don't use, just do the probes for both. I'm doing the fucking probe lighting spherical harmonics bullshit. It's kind of kicking my ass, to be honest. Oh my gosh, it's who baked the bread? See? It's just ghost lights from the ground now. You hate to see it. You hate to see it. I think you want false on this. You don't want it to check. You want it to not have backface culling. what I'm trying to do right now is I'm trying to get it to be bright on the floor. Which this kind of made it bright on the floor, but it also made it so that it's kind of bright for no reason as well on the floor. Let's try this. Let's try not inverting this direction. Oh my gosh. This is bright now. I gotta make it so that we have like a reset button where the mesh goes back. I have to hard code that in. This is, I think that this is, yeah. The fact that it's green on that side, it's supposed to be, yeah, that's probably not right. Yeah, who knows? Who knows? What I'm trying to do right now is I'm trying to make it so that the probes also get indirect bounces. Maybe I shouldn't be doing that though. Maybe that's stupid. The way it looks right now though is that like if you have the green kind of cube thing, only the top gets shaded and then the bottom doesn't get shaded. So I thought that this was something where the indirect could help. But maybe all it's doing is just making it brighter, which you don't really want either. Actually, you know what it might be? It might be this. It might be this that's the problem. It may be that the light intensity is different from when we calculate it. Yeah, that might be what it is. Although, yeah, that's probably what it is. It's probably fine as long as the light intensity is enough for it to light up. Yeah, that just doesn't feel right for me. I want to see what the dot of the normal usually. I want to see what this is usually, just on average. Yeah, that's what I thought. Always less than you know, 1 of course, but so this should be 1 at most, right? I'm not sure. Now that we have this working, let's try turning this to true for the backface culling, just to see what it looks like. I gotta get. I feel like that's pretty much it, actually. God fucking damn it. It's just, it pushes it so fast. Because there's no friction to stop it. Okay. Okay, we have to put friction to stop it. That's necessary. Actually, why isn't friction stopping it? It has friction. PC apply velocity has, it doesn't have friction. It doesn't. It doesn't have friction. It doesn't. I think friction should be implied in the function that we did earlier. But some reason it isn't. Yeah, I'm not sure. I mean, me looking at the function now, it looks like actually no. It looks like no. I mean, it should. If restitution is at 0, it's at 0.4. Is it not colliding with the ground? And how long have I been how long have I been using C? I wish I could help, but I'm too fried. That's all right. I've been kind of fried the whole day. I think it's, wow, it's so late already. Jesus. How long have I been working? Probably like 2 weeks. Probably about that. I've been writing C for 2 years, maybe a little bit more than that. Huh. I want to see what the impulse is and what the J is. Let's see what the impulse is and what the J is. Okay, so first of all, that's not the J, that's the restitution. It's the mass and then that's the J, and then that's the Vn. Okay, so when we nudge it, it should be continuing to hit the ground when we nudge it. Impulse 0. Okay, let me Google this. How does friction work with impulse 3D physics? I thought that friction would be implied when you have an impulse, but friction is perpendicular to the collision normal. Tangential input. A frictional input to oppose this sliding motion. Right after resolving the normal bounce, the engine looks at the object's relative velocity moving across each other's surfaces, the tangent vector. This is what I had down here, which was Vt, which was the scale of the normal Vn, and you subtract the velocity. I'm going to guess that that's the relative velocity. And then you apply this. And then this is the impulse. So let's just try that. Let's try that. And then you multiply it times this mu constant, I think. And this vel isn't going to be this vel, it's going to be relative velocity. All right, let's try that. Let's see if we have friction now. That's what I had yesterday. But then I got rid of it because I wanted to work on the other stuff. So are you stopping? No, you have to stop. Okay, let's try giving it a bigger mu. Can you fucking stop? Come on, bro. Like, can you fucking chill? Stop. Also, it's lagging because of the printouts, I know. Dude. It just refuses to stop. Wait, maybe this should happen regardless if Vn is less than 0. No, but we're still printing out every time. We're still printing out every time. So Vn has to be less than 0. We just get rid of mu completely. I'm perplexed on this one. Why this is not making us go any slower. If anything, it seems to be going fast, just going with a mind of its own. Okay, it finally hit 0. Okay, well, I guess maybe this isn't the... What is the equation for the friction impulse? Come on. Come on, Google. VREL... Calculate effective... Solve and clamp impulse. Oh my fucking god. Alright, this might be something that I have to leave till tomorrow. Find the relative velocity vector at the exact contact point, including their linear velocities and angular velocities. Right. Yes. Project the velocity onto the contact surface plane to find the sliding direction. Project onto the... Yeah, so that's the Vn. That makes a lot of sense. That's the Vn. Calculate the effective mass. Yeah. Oh, so you're telling me that I already have it. You're telling me that it's just this. You're telling me that it's just this. Oh, well, fucking great. Thanks a lot. What? Okay. Okay, whatever, bro. It just, you know, gave me, I was like reading it, and I was like, oh, wait a second. This is the exact formula that I already have. This is the exact formula I already have. At the end, do you scale it by the normal? By the tangent unit vector. Tangent unit vector. Oh, hey, what's up, bro? Added to object A and subtracted from object B to simulate surface drag and spin. So you're telling me that I have to flip the sign here? That feels wrong. That feels wrong. That feels very wrong. It's just gonna go through the ground. Yeah, I don't know. What am I working on? Well, I spent today working on lighting probes and some physics stuff. But the physics stuff I don't really understand. Let's try getting rid of this. Right now I'm trying to fix it so that it has friction. At, you know, some level of friction, but it appears to just like to move in a straight line. Let's actually try something. Let me print out the velocity. Let me just print out the straight up velocity every time. Just to see if it's changing, because obviously we can't tell that it's changing. It changed once. It is really tiny. It is really tiny. It is really tiny. I do wonder if you like, if you bump the mass up, it will probably slow faster. Okay, no, it... What? 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 Why does less mass make it harder to move? Explain that to me. Explain that to me, who coded it. Wait, is it picking up velocity? The velocity is changing, but it's not slowing down. Fuck. I don't know. Do I like piracy games and sharing them for free? I don't know if I'm legally allowed to answer that. Yeah, I probably have to work on this later. I don't know. I fucking have no clue. You know what I'm realizing? Like, maybe... Hmm. Hmm. Yeah, I'm probably leaving for the day. I'm tired. Yeah, that just fucking disappeared. So that just fucking disappeared. So yeah, I don't know. I don't know. I have to read more of the book. Yeah, that can't be right. That just can't be right. It may be that I need the angular velocity to do that, and I'm just skipping out on the angular velocity for now. And so it may be that I just require the angular velocity to do it. So that's probably the reason. If I look at my formula from earlier, yeah, I don't know. I'll figure this out later. I need to lie down and watch the new watch DK versus Gen G, bro. That's what I have to do. That's what I'm gonna do. I'm gonna get a sparkling water and I'm gonna watch DK versus Gen G, and it's gonna be fucking sick, bro. Don't tell me if someone knows who wins. Just shut up. Do not fucking tell me, because you're gonna ruin my day if you know who wins. I'm not very good at English. I speak Arabic. If you need any help, please message me and I'll translate what you say into Arabic. Oh, I mean, thank you. I think I'm just like heading out for the day personally, but I'm all good. I think the lighting looks good. It's hard to tell, but I think I got it to the point where it looks, I mean, a little bit better. It is kind of, I don't know, a bit mismatched. Like the brightness is mismatched between the lighting probes and the lighting there. I don't know if like maybe that's like something that is normal and you're just supposed to multiply it by some scalar value to, you know, make up for it or whatever. But like here it seems good. Like that seems better, but you just have to multiply it by some value, which is kind of just janky. Oh, also something else, we didn't do this, so it's getting both lights, so that's probably a little bit of what's happening here. The both meshes are getting the probe lighting when it should just be this mesh. It also might be some slight coordinate mismatch. It would be pretty slight though. It might be that as well. We do divide it twice. So yeah, it could be that. But anyway, I think that's it for me. Let me just try taking away this +1 for a second. Yeah, dude, the friction. There's no friction, so it just keeps picking up velocity. It's like, dude, I'm trying to move it through. It's like... Yeah, I don't know. All right. That's it for me. I'm going to probably do some Googling to figure out why this is the case here. I think I'm missing key parts of the equation, and also the annoying thing is really the how to find the EPA contact points, which obviously I failed at earlier, and that's been kind of bothering me that I failed at that. I still don't know how to do that. I just kept on getting zeros back. I did try B here, right? I'm pretty sure I did. I tried everything and it didn't work, but yeah. I think it might be I don't know. I looked it up and it said this was what to do, so I'm gonna have to do some testing later. Alright, peace out.